like literally half.
Hey, look out. So here's what we're doing today. Okay, so we started working on this, just kind of got an introduction. It takes a while to kind of get everybody familiar with the calculator. I would say, with regard to what we did last time, one of the most important things you should remember is that when you look at a graph of position, velocity, acceleration, do not see the particle. This isn't the particle. The particle didn't go down, didn't go up, okay? This is just a bunch of numbers represented by points that tell you information about the particle. So you've got to get clear in your mind. This is just information about the particle. It isn't the particle. Like I hate when teachers say, oh look, you can see the particle moving. Like you don't see the particle here at all. Okay? It's just numbers. Okay? I need to get a hat. It says on it, I am the particle. I'm not kidding. During the AP test, you want to think of me, not this. Seriously, you read the problem, like, oh yeah, Mr. Smith is the particle. And he just walks back and forth like this, okay? Got it? Okay. So, today we're finishing this. We'll do a bunch of it together. Whatever we don't finish together, you'll just do at home. Then you'll do this at home as well, okay? It goes pretty quick, but just caution. Make sure you're not just filling it out. Make sure every time you write something down, you pause for just a moment and think, okay, did that make sense? Okay, it's not collecting numbers, you're making sense of the numbers. Okay, so you should have that on your calculator already. If you have deleted it, put it in quick, go. So we put that in last time, so it should still be there. But nobody steals these. If you're having trouble with this wave, I'll come help. So this window goes from -2 to 7, and then zoom fit.
Wait, this is what you're looking for? Or is it?
It doesn't really matter as long as you get the right formulas. So. This window goes from -2 to 7, then zoom fit.
Oh, wait.
If you're having trouble, just wave at me, I'll come help.
Wait, is that
Right, so when I say window, the y values are hard to figure out in a lot of problems, but in many problems the x values are easy. So what I always do is just choose your x min to be this x max to be this x, and then zoom 0. There we go. Okay, next thing. Okay, once we get everything loaded, I changed my window from 0 to 0.3 so I can see a little better what's going on. So window that, you should see this on the screen. So go 0 to 0.3, zoom fit. Okay, having trouble? Please.
He would. Wait, oh. Yeah, me too. That is hilarious. so frustrating. No, it's hilarious. At least it's like you're trapped. You can. Yeah, I can. There's a half. I know, but there's a faucet. There's no faucet. It's a drinking fountain. Harry, that just makes it so much more enjoyable. You're just gonna grab things and then you're gonna see your drinking fountain and
You just do zoo, zero.
Okay, look out. Oh, please.
Oh yeah.
Trouble?
I don't know what I'm doing wrong.
do you want us to Oh crap, nice. Okay, how many islands should I usually
Anybody else? Okay, look up. I can't remember if I said this last time or not, but it doesn't matter. You must memorize. Velocity is the instantaneous rate of change of position. Okay, you don't have to memorize the words. You have to memorize the idea. The idea is, if you're looking at a velocity graph, so back here on the calculator, if I hit trace, the window 0.3 here. Okay, when I'm on the calculator, if I hit the trace button, so I can view some values. So trace, I make sure I'm on the velocity. Right here, look. Okay, come on, make sense of this. This is telling you that at time equal 0.15 seconds in this story, the position will be changing at that exact instant by negative 0.2. So at that instant, you could see the particle, points for the whole room. This says the velocity at that moment is negative, meaning the particle's position will be changing by 0.2 negatively. So raise your hand, please. Particle going left or right. Okay, let's come on. At that moment, that exact instant, is the particle going left or right? Sophie?
left.
How many do it? Point. For Sophie. So look, when I write on the worksheet, don't talk when I talk. When I write on the worksheet, velocity is the instantaneous rate of change of position. You don't have to remember the words, you have to remember the idea that at a given instant, if you check the velocity at that instant, you'll know exactly how fast the position is changing at that moment. Okay? That's why it's instantaneous rate of change. Question. Cool? So then back to the worksheet. It says, what is the velocity of the particle at time equals 0? Just use your calculator, hit trace, make sure you're on velocity, 0, negative 1. So I now know the velocity at time 0 is negative 1, and make sure you use units. Wade, if you need to see that again. So you're on the graph. You hit trace. Okay, make sure you are on the correct plot. So this is position, I want velocity. So up or down, we'll move to the correct plot. Make sure this says 0, -1. If this doesn't say 0, just type it in. If you need to see it again, just wait. Whoa, moving on. Position at time 0. So I go back to the calculator. I find the position is 0. What does the symbol represent? It represents the position of the particle at that time. So, question. One other thing I've done here, I think I showed you this last time as well. To be able to see the velocity and the position better, I turn off the acceleration. So I went to y equals. I highlight the acceleration graph right here. And I press enter. That turns off acceleration. So that way when I do zoom fit again, the graph is a bit easier to see. And that's what I've got here. So, question. So what I did is on the calculator, I went to y equal. The equal sign tells you whether or not these will plot. So I went to this one. Like that, so I'm highlighting it. Then pressing enter would turn it back on, and I just turned it off. Now I want the graph to readjust itself, so that's why I do zoom fit again. So zoom 0. Does that make sense? Cool. There we go. So back here, okay, once again, the idea is not just to copy or memorize, the idea is to make sense of it. At time equals 0, that's this moment right here. There are two ways to determine that the particle is moving left or right. Here are the two methods. Look at your position values. The position is 0. If I use the calculator, I can actually see the real numbers. So go trace, go to time equals 0. So at time 0, the position is 0. If I go forward in time, the position becomes -0.049. Now the position going forward in time, -0.081. So raise your hand and answer. Based on these position values, is the particle going left or right? Raise your hand. Come on. Based on those values, is the particle going left or right? Look at the position. Remember, this is not the particle. These are just numbers telling me something about the particle. So it's telling me at these different times, these are the locations of the particle. So as you see these locations becoming more and more negative, you conclude the particle is moving left. You conclude the particle is moving right. Let's go, Julia.
Left.
Somebody vote left. Point. 2 for Julia. Okay, something else you can look at is look at the velocity. Okay, during this entire time, when those position values are becoming more and more negative, the velocity values are strictly negative. So whenever the velocity is negative, the particle is going left. You need to remember both methods. Question?
So you can look at either one.
Either one. So I can observe the position and see, hey, my position values are becoming more and more negative, so I know I'm moving left. Or I can look at my velocity values being negative, the particle is moving left. So negative velocity means the particle is going left, positive velocity, the particle is going right. They'll mostly test you with velocity, to be honest, but question. Oh, back to the worksheet. So what you need to do now, okay, take a moment, write in your own words what we just discussed, like the two ways of knowing that the particle is moving left or right. Just write it however you think of it. Then I would flip in the back and compare what I wrote and make sure that the two answers make sense to you. I'll just walk the room, just stop me if you want to pass me around. Somebody's getting a call.
Sorry. You know those tile things?
Free, you know.
You know those tile things? Oh, they like help you find your phone and it just went off.
Oh, there you go.
I'm sorry about that.
All right.
Hey, I didn't make sure that doesn't. I do it all the time. This is
Very
cool.
pleasant. Very relaxed.
How do you know which line is which? I mean, like, I know I'm not trying to figure it out, but like, it just takes it. I already know that.
Hopefully it doesn't get pressed.
That's cool. Oh, the twisty one.
Okay, here we go. Okay, any questions? Next one.
Just if the accelerations are negative at all, it's like,
What's that?
if the acceleration values are, or the velocity is going negative, you know?
Listen close. Hey, no, Matt. Josh has a good question. Okay, look up. Okay, Josh has a good question. Everybody look. This graph of velocity, just say it out loud, please. Right here, is the graph increasing or decreasing? Say it. Louder. Increasing. It's going up. The values are negative, though,
Because like, yeah.
because here's the x-axis.
Okay, yeah.
And then here the graph is going down, but the values are still negative. So for this question, I am not paying any attention to the increase or decrease,
Just whether it's positive.
just whether the velocity is positive or negative. Good question. There we go. Okay, next thing on the worksheet. So this is just saying the same thing, and I just tried to reinforce the idea. So the position is decreasing at time equals 0 seconds, and the velocity is negative 1 at that time. The particle is moving left. So either indication would tell you the particle is moving left. Questions? Okay, look back here for a second. So this is on the front of your worksheet, this graph again. It kind of goes back to Josh's comment. Okay, right here, there are two key things I noticed. These position values are positive. That tells me something about the particle, because all these y coordinates are positive. This portion of the position graph goes down. That tells me something about the particle. So raise your hand if you can answer this. Seeing that these y values are positive, what does that tell me about the particle? Brand. Like each of these y values, this is, let's see, there's 100, there's 120, there's 80, 60, 40. each of those y values are positive, what does that tell me about the particle? If you don't know, talk to someone who does. Like, what does it tell me about the particle? Okay, look out. Okay, I'm asking the question. Listen, come back. Okay, I'm asking the question specifically to make sure you see the difference between, hey, seeing these y values being positive, that tells me one thing. Seeing the y values go down, the curve decreasing, that tells me a second thing. This tells me the time period. Okay, so what does seeing that these are positive tell me about the particle? Hands good. Come on, show me. What does seeing that positive tell me about the particle going?
That they're on the right.
Perfect. So I'm the particle, just means I'm over here. Everybody knew it? 0.2 for Lauren. Okay, now look, curve's going down. So hands up. When you see these y values decreasing, what does it tell you about the particle? Let's go, Aisley. How many knew that? 0.2 for Aisley. Perfect. You see the difference, right? Good, good. The teacher, that's the worst thing you can say. I try so hard not to do that. You go, right? Like, what were you supposed to say? No. Okay, so try not to say. Just ask questions. Next thing. So we already did that. We did that. Here we go. Okay, new concept. We already found the velocity. You can just write that down. -1 meter per second. The velocity at time 0.1 you can find on your calculator quickly. You just trace. Make sure you're on the velocity plot. Type 0.1. Press enter. -0.406. Again, it doesn't do any good just to watch me, so just wait if you need to show that again. Just go like this. So the worksheet asked for the velocity at time 0.1. So I went to my calculator, hit trace, and I'm on the wrong plot. I need to be on velocity. So I move the arrow, and then I make sure I have a 0.1 like that. That help? Okay. Keep asking. Anybody else? Sweet. Okay, new concept. Speed. Okay, in the same way that it is important that you look at the picture and you keep telling yourself, I do not see the particle's movement here. The particle doesn't go down. I just see numbers that tell me things about the particle. In that same way, and then remember, I am the particle. I'm going to write a book. I am the particle. Catchy title. Never mind. Okay. Speed. Speed and velocity are not the same thing. So don't ever make them the same. Question, Abby, sorry.
I just have, I don't know how I can put an X on my calculator for the Y.
So you're okay. Do you know, is there a different way to get the value? That's all we really care about. As long as you get the value, you're fine. Like you can specify specifically what X you want to find the value at. There might be one like this, Abby. On the 84, you can go to this menu and choose value. There could be a similar function on yours. Like the same menu that uses to find intersect and that sort of thing. Once you choose value, Abby, like so, then you can tell it which one you want. I'll let you play for a second. But, you might have to stop by at lunch or something. We'll have to work on it together. I can usually figure it out. I just don't remember. But get back to here. Speed. It's really simple. Listen, if you know the velocity, just throw away the sign, like the negative, and now you have the speed. Okay, so the only difference between speed and velocity is the velocity includes a negative or positive to indicate direction. Speed has no, speed is just always positive. So the negative tells me the particle is moving left, and I can tell you that I know the speed of the particle is 0.406 meters per second. The velocity is negative 0.406. Okay, you need to talk through that again this way. So I'll give you some points, Mary, just help me. So if I tell you the velocity is 7, which way is the particle moving? Right, because the velocity is positive. What would be the speed of the particle at that moment? Just 7. Just 7. So velocity and speed are almost exactly the same thing. Is that okay? If I tell you the velocity is 10, which way is the particle moving? And what's the speed? Perfect. If I say the velocity is -3, which way is the particle moving? And what's the speed? So speed's just 3. Is that hear the difference?
Yeah.
So velocity 10, speed 10. Velocity -3, speed 3.
Okay.
You good?
Yeah.
3 points. Ashley.
So that's like the speed is like the absolute value of the velocity.
Perfect. Perfect. So Marin, what Ashley said, 2 points for Ashley. Speed is mathematically the absolute value of the velocity. Or sometimes people say it's the magnitude of the velocity. Anybody else? Awesome. Okay. So, it says here, between time 0 and time 0.1 seconds on this graph, having done this before, 0.1 seconds is about right here. It says, is the particle speeding up or slowing down? So we look at the velocity, and we notice that here the velocity is very negative. In fact, I think it's -1. You go back to the graph, go trace, get on velocity, 0.0. So the velocity starts at -1. Just say it out loud, please. What's the speed? Say it. 1. So I go forward in time to this time. The velocity is now -0.5. So which way is the particle moving? Say it.
Left.
Louder?
Left.
Okay. What's the speed? 0.575. So from here to here, just say it. Speed up or slow down?
Slow down.
Slow down. It's moving left, it's getting slower. Okay. This means that feels really good to me. That made perfect sense. This means I still don't really see it. Please, point with the horn.
Okay, so, like the position, as it gets closer, it gets to the right, but it's still negative, and it's right moving half the time. But then since the velocity, like this one, if it's moving towards the positive, does that mean, I guess,
So here we go. Look up. A few people did this, so watch. All you're paying attention to, so again, remember, speed and velocity nearly identical. So I just look at the numbers and follow what they do. So starting at time 0, the velocity is -1. So the speed is 1. Which means the particle's position is changing by 1 meter every second. It's going that way, 1 meter every second. If you go forward in time, okay, now my velocity is only -0.5. So I'm still going left, but my position at that moment is only changing by 0.5 meter every second. So I'm moving slower to the right. I go forward in time. Now my position, my velocity is -0.2, so my speed is 0.2. So as I move to the left, I'm going slower and slower. We want to talk about it. Cool. Do it again. Just be honest. If it still feels fuzzy, do this. Like, I gotta know. So show me. So this is good. This is fuzzy. So always be honest. You just have to know how you're doing. Points for the whole room. I'll pay somebody some extra credit just to raise their hand and say in your own words how you can look at this graph and know the particle is slowing down during this time period. Justin?
Would it be if you're getting closer to zero, you're slowing down?
It is true on any graph of velocity. Let's go back to this big one here. Right here, the velocity values are becoming less negative. That means the speed is becoming less and less. But the graph's getting closer to the zero. I'm slowing down. Right here, the velocity values are becoming more negative. The speed is getting higher. Here, the velocity values are becoming less negative again. The particle's slowing down again. Here, the velocity values are becoming more positive. So the particle's speeding up again. Good point. Question, please.
So as it crosses the x-axis, does that mean that it's the velocity is zero, so it's not moving?
So right here, Carson's got it. The value of the velocity is zero, and at that moment, the particle stops. Just say out loud, please. What direction was the particle traveling just prior to that moment? Say it. Left. Look at the numbers. The velocity is quite negative. Right here, the velocity is negative 60. Now the velocity is negative 40. Now the velocity is negative 20. So it's moving left, but as it's moving left, its speed is 60, 40, 20. Slowing down. Now the velocity and speed becomes zero, the particle stops. So it literally stops for that instant and then starts going the other way. Show me 1 or 0. That little explanation made sense that Carson talked about. You give yourself a point. You're doing pretty good. Okay, back to here. Again, as you're doing the homework, just make sure, like there's an answer to every problem, and I tried to be pretty thorough in the wording. So just make sure you think for yourself, hey, I'm pretty sure this is right. Check the back, read what I wrote. Gain confidence that you're thinking correctly. Not just come spend some time after school. So write down how you know the particle's slowing down. Go. Yeah, I've already done that. What he meant was the velocity graph. So it only applies to velocity. So here's velocity. So this velocity is negative. I can't so 160. So then this would be negative 140. So the velocity is doing negative 160, negative 140, negative 120, etc. What's the speed? Right, because you're going speed of 160, speed of 140, speed of 120, speed of 100. So he's noticing that as I follow the graph, because the white coordinates get closer and closer to the horizontal axis, he said, oh look, the velocity is getting closer and closer to zero. And it's true. As the velocity gets closer and closer to zero, the particles slow. Any velocity graph, the velocity values are closer to zero than they're going down. So here, though, because here again the velocities are like about negative 60, negative 40, 20 is where the speed slow down. But now the velocity is 20, 40, 60. So now my y coordinates are going away from zero. That's where I get my closer. Okay, next thing. Any questions here? Anybody? Well, look fast. So the wave is off, so that we come up. So you went from 0 back 0.
Zero, say again. And then you change your back.
So here, just restating what we just talked about. From time 0.1, the velocity becomes less and less negative. On the AP test, any G period is a valid abbreviation, so feel free to use that all year. The graders accept that, so moment by moment, the particle is moving less and less to the left. And as the particle is slowing down as it moves to the left. Questions? Well, next page. Close this blind, the sun came out. So. Okay, new concept. Okay, watch me. I'm the particle. Watch. Okay, I have a location, and the story is telling you that my location is different at different times. Okay? If you look up, make sure your phone's going away. So if I'm over here, my location might be 15. Okay, that's my position. It's where I'm at. I'm at 15 meters. But if I'm here at 15, and I go left 5. Don't overthink it. Raise your hand. Tell me, what's my new position? Yeah. What's my new position, Kylie?
10.
Somebody knew it? Point. She's for Kylie. Focus. I was at 15. That was my position, 15 meters. Now I'm in a new position, 10 meters. Okay, they have the same units, but my position changed. Raise your hand. By what amount did my position change? By what amount did my position just change? Dawson.
5 meters.
Somebody agree? Point. 2 for Dawson. Okay. One subtle mistake in that. One subtle mistake. I was here at 15. My position changed to 10. Okay. I could have been at 15. My position could have changed to 20. You have to be able to know the difference. So if I'm here at 15, my position is now 10, hands up again. What's my real change in position? The last one was slightly wrong. What's my real change in position, Howard?
-5.
How many do it's -5? Good point. 2 for Howard. Okay, so it's crucial you can process the difference. 10 meters, that's a location. That's where I am. -5 meters, that's my change in position. As opposed to a location of -5 over here. Okay? Pretty good? This or this made sense. Go. So this is good. It's like a computer. This is yes. This is no. You design digital circuits. You think of 1 is yes, 0 is no. So, cool. Point for the whole room. Okay. So that's the difference between position versus change in position. Look up. I'll let you kind of do these numbers at home. It's no big deal if that makes sense to you, okay? It's just really quick. There's one other one that won't show up on the paper today, but we might as well throw it in because it's related. Watch close. I'm here at 15. I moved to 10. Say out loud, what was my change in position? 5. Okay, the other one they ask you about is they'll say, what was the distance traveled? And that's always a positive number, so that's just 5. Where distance travel becomes more important is when I do something like this. I'm here at 15. I move 10, and I move back to 15. Hands up. What was my change of position ratio? What was my, and the other word for change in position is displacement. So what was my displacement, Koji?
0.
How many do that? 0.2 for Koji. That's my displacement. That's my change in position. For that time period, even though I started at 15, went to 10, went back to 15, I did not change position during that time interval. Okay? However, hands up, what was my distance traveled? Chris?
10 meters.
How do you do it? 0.2. Okay. Any questions on that? So again, I'll let you fill out the worksheet. That's pretty easy if that makes sense. So next step. Okay, earlier we said that velocity is the instantaneous rate of change of position. And I believe I said that the words aren't really that important other than instantaneous. What's important is you make sense of the idea. If I say my velocity is -1 meters per second, that's telling you at that exact moment, my position is going to head that way 1 meter every second. That's what velocity means, okay? Average rate of change of position, or average velocity, is by what amount on average are you moving that way? So let's do this computation here. So I guess we got to go backwards here. So back here, the position at time 0 turned out to be 0. Position at time 1, here's the graph. You use your calculator, so you'll figure out that the blue graph right here, at time equals 0, position is 0. Use your calculator, you can figure out that at time equal 1, the position is -3. You would need me to show how to do that again on the calculator this way. So back here, I want a window from 0 to 1. Zoom fit. So there's my picture. I want to trace. I'm on the position, that's good. So I go to time equal 1. So there's time 1. Press enter. Comes right over here. Tells me right there when time is 1. Remember, this isn't the particle, these are just numbers, but it's telling me at time 1, the particle will be at a position of -3. Anybody else? Just wait.
I'm confused about which graphs, how you know which graph you're on.
Oh, perfect. No, good question, Sydney. 2 points for that. On your screen, there should be something like this. It will say Y1 or Y2, and that's where you just have to remember where you put it. So if you look at the front of the worksheet, we said we were going to enter these 3. So most people just put this in Y1, Y2, Y3. Does that answer your question? Yeah. So when you're on the screen, I just always look for the little prompt. And I look at the cursor and say, oh, I'm on the velocity, I'm on the position right now. So if I type in 1, it'll tell me the position. Is that your question?
Yeah, and then I'm just
Go ahead.
wondering, how do you know, well, like for number 8, if it's asking for like the red line, orange line, and the blue line?
Gotcha. So you're good to hear.
Well, yeah. I guess I'm just a little confused, like how you know which line you're tracing. Are you just tracing one line, or are you doing all 3?
Oh, gotcha. So for these, I'm just tracing the position graph
So the blue line?
because position is X.
Okay.
So this says the position at time 0 is, and that's why I went to the blue.
Oh, because of that on the front.
Correct.
Oh, that makes sense.
Does that answer your
Okay.
question? Works. Pretty out. Cool. Okay, look here. My position was 0. My position became -3. So if I subtract them, it's -3. Subtract 0, you're going to get -3. That's what we just talked about. That's the change in position.
Also on like 8 millimeter, so if it has X and then a number where you do the position graph.
So the way you read this, 2 for Justin, look. Hey, let's get everybody to answer this. So raise your hand if you know. When you see that symbol, what graph are you looking at? Show me your hands, come on. When you see that symbol, what graph are you looking at? So, Christian?
Position graph.
How do you do it? Point, 2 for Christian. And then it's telling you at what time you're looking at the position graph. Time equal 1. That's why we're over here. Okay, this box that this symbol that I've drawn a box around. Show me your hands. Is that symbol inside the box, is that an X coordinate or Y coordinate on the graph? The symbol inside the box, is that an X coordinate or a Y coordinate on the graph? Show me hands. X or Y? Let's go, Sarah.
Is it Y?
Somebody agree with Sarah? Point, 2 for Sarah. This is the Y coordinate. It's the Y coordinate at an X coordinate of 1. So it's the position graph. See it? It's over here when X is 1 or time is 1, and it is the Y value. Equal means these are the same. So it's saying the Y value on that graph is the same thing as -3. They're the same thing.
So like if, and then they would say like V at that point would be velocity.
Perfect, perfect, Justin, perfect. There we go. Cool. This is between those 2 times. By what amount does the position of the particle change? Changes by -3 meters. That's just change in position or displacement. So
Did you just say meters per second?
we wouldn't say meters per second because we're not talking about the velocity, we're talking about the position. Like by what amount did the position change? So. Now the next one, Josh, now we go back to meters per second because we say, first a comment about this formula. Hey, you will need to know how to calculate average velocity. So your options are memorize these 3 different formulas and pick the one that makes the most sense to you, or do what I do. I don't memorize the formula at all. I just memorize the idea. Average velocity just means, well, hey, 1 second went by. Well, during that 1 second, how much did my position change? -3. It occurred over a 1 second time period, so you just divide. Take the change in position, divide by the change in time. So I don't need any of this. In fact, I think it makes it harder. Like it's easier just to say, hey, right here, the graph showed me that the position was 0. Here the graph shows me that 1 second later, the position is -3. So I just look at the Y coordinates and say, hey, the position was 0, it became -3. So I moved 3 that way. And I did it in a time period of 1 second. That's average velocity. So -3 meters per 1 second. That's exactly what this is telling you. Change in position divided by change in time. That's average velocity. And then the wording just explains that. Particle's position is changing by -3 meters every 1 second. We want to talk more about that.
So when you say like average, like does that like mean be like between 2 points that wants the average, or like just like a specific spot?
It's what it's really saying, rather than 2 points, I know that's correct. It's really saying for this time period, for this 1 second time period, on average, what is the velocity of the particle? If you look at the calculator, so we go trace again, we follow the velocity. Okay, the velocity starts at -1. Watch those numbers. Okay, oops, too far. Interesting. Okay, key point is this. During that 1 second time period, raise your hand if you can tell me, how many times was the velocity -3? Show me hands, it's not a trick question. you followed it. We got window 0 to 1 here. Zoom fit. Come on, come on, come on. You watched me trace all those different velocity values. How many times did you see the velocity equaling 3? -3. Come on, show me that. As you trace this curve, like right here, the velocity is negative. Just watch, you can do it now. Right here, the velocity is -1. Now the velocity is about -0.5. Now the velocity is back to -1. See, there's the velocity is -2. Now the velocity is -3, then -4, -5, -6. So how many times in this 1 second time period was the velocity -3? So Sydney? How many agree with Sydney that it was once? 0.2 for Sydney. So during that entire 1 second, the velocity was actually only -3 once. But for the 1 second time period, the average velocity is -3. Because velocity tells you how the position is changing. The beginning, say it out loud. What was the position at the beginning of this time period? Say it. 0. What was the position at the end of the time period? -3. So say it. How much did the position change in that 1 second time period? -3. That's what velocity is. How much the position changes. So because the position changed by -3 in that 1 second, that's the average velocity.
Okay, so say they like gave us like between 2 seconds and 5 seconds. Would you have to use 2 points, or could you still stick to the 1 point?
Oh, everybody can answer this. Okay, come on. It's a really good way to check to see if you're making sense of this. What Justin said, 2 points for asking. He said, what if I need to find the average velocity from 2 seconds to 5 seconds? Okay, without knowing the numbers, somebody tell me, what information do I need to figure out the average velocity from 2 seconds to 5 seconds? What information must I have? What hands? So how?
Start position.
Perfect. I need to know, where is the particle at 2 seconds? Where is the particle at 5 seconds? Once I know that, do it quick, watch. Come on. Concentrate hard here. Just make sure this makes sense. So I can zoom fit 2 to 5. Okay. I can go trace 2. Position's -26. 3 seconds later, position is -155. So what was it here? I can't remember. Help me. 26. So from -26 to -155. So type it in quick. So what's the difference between those two? How much did the position change in that time period? What is that, Helen? And negatively, right? Like we went from -26 to -155. So my position change was -129. So let's write that down. Just over here in Scratch. So I changed my position by -129 in that 3 second time period. So if I divide that by the time period, do it for me, Hallie. You're good. So on average, the particle is moving leftward 43 meters every second. It isn't really moving like that, but on average it is, because it has to get from that position of 26 to that position of 155.
So basically, it's you take the difference between the two positions and then divide by how much time went by.
Right here.
Okay.
Perfect. Look, you find the position at the end, subtract the position at the beginning, divide that by the time at the end versus the time at the beginning. Okay? Question? Cool. Next thing. Did I answer your question? Perfect. So go to 12. Okay, we've talked about pretty thoroughly there what is meant by average rate of change of position, average velocity. Instantaneous velocity is what's the velocity at a given instant. So here's some notation for that. So this symbol, look at the difference. So that's V average. This is v instantaneous, the velocity at a given instant. New symbol, we'll worry about it a little bit later, but this is known as the derivative. Okay? This symbol means the same thing. It means the tangent slope of the position. So when we found, look here, when we found this value, -3, that was the secant slope of the position graph. Secant slope means draw a line between the 2 points. So I start here, I draw a straight line to there. Is that decent? Time to pause. And it has a bit of a curve because it's hard to draw a line without using your arm as like a radius, right? That's decent though. Pause to admire for a moment. You gotta find the high points of the day, Marion, you know? Decent line. So look. Well, you know, show up for dinner tomorrow. How's the day going? I drew a straight line today in 2nd grade. One shot, you know, didn't take 2 tries. Decent. No, just the ruler's too easy. Hey, the slope of that line is -3. It's the secant line, okay? Now look here. Instantaneous rate of change is the tangent slope. So they say it's 6 seconds. So go back to my calculator, get a window to 6. So I'll go 0 to 6. Zoom fit. Okay. The worksheet shows that, like my screen shows that same graph right here. So I'll work here, it's a little easier with the pen. Okay, so at time equals 6, here's time equals 6 on the position graph. Instantaneous rate of change is the tangent slope of the position. So, everything moved to, there we go. So right there, if we draw a tangent line will look something like this. Dang, missed. Try again. There we go. Decent. Curves a bit at the top. Okay. That's the tangent line. That slope is the instantaneous velocity. The secant slope was the average velocity. Tangent slope is the instantaneous velocity. That's it. Question? Let me show you how to find that on your calculator. Let's go back to here. Okay, there's a way to do it from the graph, but I have found that on the 83, that sometimes gives an answer that will not earn you the point on the AP test. So I prefer not to show that method. So from the main screen, and another problem with the 83 is it doesn't work quite like I'm about to show you. That's why I kind of encourage, if you can afford it, to get the other one. If you can, it's okay. But on the main screen, if you have an 84, you're going to type Math 8. If you can't afford to rent, come talk to me. I'll try to find a way to help. So just come talk to me privately. So your Math 8. You should get this. Math 8. Math 8. Are you okay? Chris won't get that. Okay, if you have an 84, listen. If you have an 83, it's never going to work. Okay? You just won't do that. Okay? That's why I'm trying to get you to rent. If you can't rent, talk to me. Okay? If you have an 84 that won't do it, I can fix it. You just have to stop by at lunch and I'll upgrade it. It takes like 3 minutes. Okay? But anyway, you're right here. Watch. Okay, this is an easy way to remember this. Raise your hand if you remember the little catchy phrase. It's not a rhyme, but it kind of has a nice ring to it for how people remember what slope is. Just raise your hand. Come on. Like when people say slope, just raise your hand. You got it. What does it say? Say it louder.
Rise over.
Rise over run. Okay, look. Watch. It's really, look, come on. It makes it super easy to remember. Come on. On this graph, which is the run, the X or the Y? Which is the run, the X or the Y? Okay. So the run is the X. The rise is the Y, right? So right here, you put X. It's rise over run. We're finding the tangent slope. Rise over run. Let's put an X. Okay. Now we need the Y. Well, we're trying to find the tangent slope of the position. We just talked about it. The position graph is in Y1. So we need that formula. So you do alpha F4. You get a list. Choose Y1. Alpha F4. No worries. Alpha F4. Choose Y1. Okay, remember, on the calculator, the X variable is representing time. We want to know the, what was it? 6 seconds. So you type 6.
Wow.
That's the slope. Back to here, look. The slope of that green line is 155. Okay, that's the instantaneous rate of change of position, just like the worksheet says. Okay? Look, it's another reason why I told you to do exactly what Carson did. You get a 3-ring binder. You just get the worksheets, take the staples out, you organize them in there. It's like it's everything you need. Like it's the notes, really, for the class you added some of your own hand notes. It's perfect. So 155 is right there. Are you with me? Wave if you need me to do it again. Cool. Okay. Instantaneous velocity. We could also do this. Look. Back to the graph. Hit trace. Go to the velocity curve. Type times 6. 155.
So instead of using that gradient, you could have gone to the velocity line and just done that.
Correct. You need to know both. Yeah, the whole idea is to know the connection.
Yeah.
That the tangent slope, perfect, Justin. The tangent slope of the position curve is the velocity at that moment. That's why the velocity's value is 155.
So if like on the understanding test, if you gave us the velocity line, we could use that. But if you don't give us that, then we don't use the position. Okay.
Perfect. Okay? Now, I also think I told you last time that if you understand how position relates to velocity, you will know how velocity relates to acceleration. It's the same. Velocity tells you how is the position going to change. Acceleration tells you how is the velocity going to change. Okay? So back to here. You got 5 minutes. Questions for anybody? So the homework is finish the orange, do the green. Okay? We've done this. This was 155. Okay, just some notation here. So at time equals 6 seconds, velocity is also 155. It's the same thing. At time 4 seconds, remember x prime, it's in the worksheet. That means the tangent slope of the position at time 4. So I just use that calculator again. Go back to the main screen. Here's what I like to do. Look up, in case you don't know how to do this. I just want to do this again for time equal 4. So I just go grab that. Because I don't like typing. So go like this. Enter. Now I have it. Back arrow. Time 4. Done. Please. Yeah. We're at lunch.
Wait, how did you?
We've got someone inspired in the room besides Abby.
Copy this.
You know how to do it? The derivative? No?
I'm close, but
I can show you, it's a little short on time, so well, I might have time at the end of the class.
Show us how to like copy it again.
Yeah, no worries. Just use your arrow. Just go up until it's highlighted whatever you want. Once you've highlighted what you want, just press enter and it brings it down.
Oh, wow.
Oh,
Then you can edit it. Okay? I hate pressing keys. Sorry, that's why I don't like the Inspire. Too many keys to press. It does lots of things, lots of keys. Question? Please.
So is it okay if mine's like a tiny bit off? It's like -48.99991.
It all depends on how much you round, so you're fine.
Okay.
Yeah, I've set mine to round to 3, so
Okay.
yeah, not a concern. The AP test says you must round to 3 or more, so I just always round to 3. Okay, look. We already talked about this, so we've done that one. Last thing before you go, okay, just like I said, acceleration relates to velocity in exactly the same way that velocity relates to position. So right here it's telling you, hey, we learned that the velocity was the tangent slope of the position. Acceleration is the tangent slope of the velocity. Okay? That was going to ring, so I'll let you go, but just wait for 1 minute. Good work, you guys. Good work.
This year,